No sound, no sound. Lots of sound. Say recording. Okay, let's jam here. So you guys, welcome. So any questions on 5253 before, and then we'll go with the rest of the stuff here. Welcome to Monday morning. Nothing. Everything good? Or we'll do it later, Mr. Angio. One of the two. Later too. Okay, so let's jump to 5.4. We covered the fundamental theorem of calculus. And what it really did is it allowed us to connect derivatives and antiderivatives, or derivatives and integrals together. And the first part was okay, right? Because you just like, hey, that's just antiderivative, you take it, right? The second part was kind of funny because you develop a function out of it. Did we finish up the function? I think we did a function out of it, right? Yeah, that's right, we did. It was a secant function, right? Secant, and then we had the extra little derivative on it. Okay, so we're moving on to 5.4. Check this out, this is so funny. Okay, allow me to draw the way I wanted to draw. Okay, so let's do this here, quick intro. 5.4 is called the indefinite, even though we have been doing this already here, but now we're just going to do a whole bunch of called the net change theorem. Okay. Boom. All right, if you have your book, or if you want to grab a book, so I think there's an extra book there, is that right? Yeah. Okay, awesome, okay. We are on page, and might as well give it to you here, page 392, right there. It's the table of indefinite integrals right there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. A whole bunch of them. And so that's what we're going to be practicing on today. So we got to remember a few things here. Why do we do the C value? Why is that a new one? Remember, because if you go backwards in time, right? We have, let's talk about it since no one answered. So whenever you take a derivative, if this is my function is, I'm going to make something in my head, right? Don't need to copy this down unless you really want to. If I have x squared plus 4, right? When I take a derivative of this guy, I give myself 2x, right? So then if I were to go backwards on it, so let's think about this here, x squared, and let's, so 1, 2, 3, 4, it's a parabola, right? Parabola hitting right here and going up. And remember, integrals are the area underneath the curve up to the x-axis, right? So let's say we go out to like 3, all that area there. And what it's saying is for that area, if I plug in a 3, I'm going to get an area of 6 underneath there. That's kind of nice. Sorry. Nope. Wrong. If this is my function. Oh. Monday morning. You guys ready? Let's erase. Okay, so that is the function. When I take a derivative, this is what I'm looking at. I'm looking at a 2x going that way. We're good? And so that is the area that I'm trying to get back up to. We're good. But here's our little problem. When I took the derivative, that 4 turned into a 0. So when I take the antiderivative, of this, I say to myself, oh, that's going to be x squared, right? 2 over 2, right? But then was the original piece, it's funny, I think don't erase it at all. Was the original one at 0, 0? The original one was at 4. But because of that little derivative being 0, we don't know what that value was. So how high was the original graph in the first place? I don't know. So we have to put this little plus c. I have no idea. To get back to that value. Okay, so there it is. So I'm gonna have to always have the little plus c at the end. Now, this only happens if I don't have any indefinite interval. Because what happens if I have numbers here, I get to subtract c. Are we good there? We'll see. Let's do one with c inside it, and we'll see how it goes out, right? And then we won't do it anymore. So the point is here, it's called definite integrals. Definite integrals, what they have is they have a c value here. So let's do this here. Let's do, I don't know. Maybe this is on, that's why. Cool, I got page 1. This is on. Let me do this real quickly here. PowerPoint is going crazy. So let me just cut off some programs here. Let's see if that will help. You're not going down. 1 second, class. This is weird.